Oh, hello and welcome. I know, Tyler, we will most likely not be going back on the 1st, but that's because the 1st is a Friday. We will potentially be going back on the 4th, but it's looking less and less likely by the day. So, we'll see. Um, I'm sorry, Izzy. Oh, my buttons aren't done. Imagine that. Nice, Simon. That's definitely. Did you tune into those BYU streams? Those are fun. Um, yeah, I'm not sure, Tyler. We'll really have to see. The latest I checked, you can check like when peak. Um, Here you can do peak COVID-19 Utah. Actually, no, you can do prediction. So you can actually look, they have some computer models that simulate like what's going to happen. And so apparently it's not going to peak until April 27th. And so the likelihood of us going back to school on May 4th is smaller and smaller. This peak date keeps kind of shifting as we get more information. So, yeah. And then deaths are apparently going to peak in a couple weeks. But Terraria is awesome. It's a fun game. Cooper, I have no idea what's going to happen to graduation. They haven't made any announcements on that one yet. I hope your cookies turned out good, Tyler. And then Izzy, how was your bread? Bread can be a tricky thing to make. No, they're definitely not holding people back a year. That's for sure not gonna happen. Them sticky buns were fantastic. I think they're better than cinnamon rolls. It's the first time I've ever made them. They're really good. Um, you you don't need a new computer to play WoW unless your old computer was terrible. Simon wants to know if people want to go visit his island on Animal Crossing. Nice, Tyler. That's impressive, Zach. Expert mode is no joke. It's kind of where I lost interest in Terraria because I just felt like I was reading guides. So, Kate, this is what BYU is currently doing. That so a lot of the colleges are giving the option that kids can, if they're not happy with their letter grade, they can just take it as a pass. But we have not said that for high school. That is not going to happen for high school. Right now, the thing for high school is you're going to get the grade that you're going to get. They've encouraged teachers to be a little more lenient, but you're still getting the grade that is going to be in Skyward. So, um, of course, your Chromebook can't run it, Drake. Oh my gosh! Stop talking about Grinder. Yeah, Izzy. So I mean, working with your classes, right? There's still tons of time left in the trimester, so there's still tons of like opportunities to get a better grade. So, Matthew, it hasn't been officially announced yet, but my bet is it's looking a little bit more like that every day. I don't know. Terraria's fun. It's a good game. It's a good time waster. It's a good open-ended ish game. I hope everybody enjoyed the break. give you something to do again. Simon with the poggers. Simon, you gotta use my pog. Good old Les Mis. Les Mis is fantastic. I'm sorry you're bored, Trinity. An actual sword, Xander? I love how everyone's just making stuff. Yeah, I don't know. You have to either sub or you have to unlock the emotes using your valence electrons. Yeah, Caden played a bunch of League. Oh, there you go. Weaver with the Les Mis reference. Okay, stop quoting Les Mis. Yes, Ellie, I did miss you. Les Mis is fantastically dark. Oh, it's so good. All right. Let's try to clear out some cobwebs. Talk about what's going to be on this. My break was good. We did some like updates around the house. I did some work on sprinklers, and we installed a couple new doors and went on bike rides. We're teaching my son how to ride a bike, so that's fun. He's getting pretty good at it. Yeah, we did a little Easter egg hunt yesterday. It was fun. Just kind of hung out. Nothing crazy. Just hung out. All right, let's talk about Canvas. So on Canvas, right, as a reminder, you have the word equations problem. So you need to make sure that you submit your word equations. No, wait, we already did that. That's old. I don't know why that's on my to-do list. That was last week. We have the total net ionic, which I'm gonna do the submission thing today, this afternoon, so that you guys will have a chance and a way to submit it. But let's make sure we remind what we're talking about. So we go into modules, right? Everything's always in modules. Hey, it's spring break. They specifically told me, Johnny, that I was not supposed to work starting Friday afternoon until this morning. So I was instructed not to do anything. They said, take a break. So, all right. So we already did all this. We already did all of that. We already did all of this. Okay, we're on Chapter 10, Part 2. That's the module that we're on, is Chapter 10, Part 2. We did this stream right before the break, right? We talked about the net ionic equations before the break. And then we have this worksheet, okay? So if you haven't done this worksheet yet, okay, make sure that you are starting on this worksheet, okay? So reminder, we've got all these wonderful equations that we're doing where they have the description, right? Chlorine gas bubbled through a lithium iodide solution, forms a solution of iodine and what? Right? So we use kind of that knowledge that we talked about to write the molecular equation, do the total ionic and the net ionic. I'm actually going to do this first one with you guys just to get you guys started on it. So that way, hopefully that'll get you guys going on this. Reminder, this worksheet's going to be due on Thursday night on Canvas, right? So I'm gonna work you guys through this. There are 10 of them, Izzy. So there are 10 problems. This is on Canvas. This has been on Canvas for a week and a half. But yeah, so again, a reminder, this is if you go into modules, right? Go modules, Chapter 10, Part 2. This is the total and net ionic equations worksheet. It says due 416. So modules, Chapter 10, Part 2, total net ionic equations worksheet. So Ellie, remember, aqueous means that something's dissolved in water, and liquid means that it's been melted. And Tyler, I don't think you can buy a dog on Amazon. 3 days to panic over that, right, Trinity? So reminder, on Wednesday's stream, we'll be answering questions. And so it would be ideal that you start the worksheet tonight or tomorrow so that you can answer questions. So Cooper, I'm going to try to get that up today, this afternoon. That's going to be where my afternoon goes. I don't know for sure how long it's going to take me to program it all in. Programming submission assignments into Canvas is a little obnoxious. But that's what I'm going to be spending a lot of my time on this afternoon, answering questions and putting all that in. So again, there's just there's just one assignment, right? Remember, one assignment a week. Okay, remember that's in the monthly quarantine calendar, right? If you haven't looked at the monthly quarantine calendar, you should look at that. Okay, so reminder, we're through this first week, we're through the second week. It's not bad. There are definitely some worse programs to use, Quantum. Yeah, it's not terrible. If for an online education software media format, it's not terrible. All right, so don't forget, right? We had no instruction last week. Yeah, there are some definitely worse ones. Okay, so we're here, right? This is today. Okay. We have one assignment due a week, so we have this next assignment due next week. Okay. All right. So again, this is going to be our first assignment. I'm going to work through this one to kind of help you guys out on these first couple ones. Yeah, I feel it on that, Quantum. I teach both a high school and a university chemistry class. My university class is a night class, though. It's on Tuesday and Thursday evenings. Okay. No, you're good, Quantum. All right. Yeah. So let's do a review of this real quick. So let me blank this out. What is that? Why is that? Oh, there it is. Okay. Whew, took me a second. Sorry. I was really confused about my screens. I would, Cooper. Specifically the ones from last Friday. I don't even have them in this notebook. So nice. Unlocking the memes. All right. So let's do that first problem. So the first problem on the canvas, right, says chlorine gas is bubbled through a lithium iodide solution, forms a solution of iodine and what aqueous? Okay, so chlorine gas. So this is number one, right? So chlorine gas. Remember, chlorine is one of our diatomic elements. So remember, there are 7 of the diatomics: hydrogen, oxygen, nitrogen, iodine, fluorine, chlorine, bromine, right? Those are our honeyfickelbar, or yeah, there you go. Cooper's got it. All right, so chlorine gas, Cl2 gas, right? And it says it's bubbled through a lithium iodide solution. I did, Tiara. Lithium iodide solution. Okay, so there's a few things we know. We know lithium's Li, iodine is I, and solution is aqueous. Now, in order to make sure this is the right formula, we need to check the periodic table. Lithium is in the first column, so it forms a +1. Iodine is in the very last column, column 17, so it forms a -1. And so if lithium forms a +1 and iodine forms a -1, then the charges are balanced, and so it's just LiI. Okay. So, so when it says solution, it is aqueous. Yes, that's a good observation, Hunter. Anytime something says solution, that's going to imply that it's aqueous, dissolved in water. Okay, so chlorine gas is bubbled through a lithium iodide solution, and says it forms a solution of iodine and what aqueous? Okay. So it says it forms a solution of iodine. Iodine's still diatomic, I2. It says it's a solution, so that tells us it's aqueous. And then it says form something else. So to form something else, we need to be able to predict what this is. Well, that means it should be one of the 5 types of reactions that we learned about. So if you look, we have an element reacting with a compound to produce a new element. So what kind of reaction is this? Do you guys remember the 5 types? So that's the other product, Matthew. But what do we call the reaction? Yeah, it's the replacement thingy, Hunter. It's a single replacement. So it does form lithium chloride, right? Matt's totally right about that, because we have a single replacement reaction. The chlorine is replacing the iodine, right? So chlorine's swapping places with the iodine, and so we get iodine by itself, and we get chlorine reacted with lithium. Okay, so lithium, reminder, we said it was a +1. Chlorine, on our periodic table, it's in the same column as iodine, and so it's actually still -1. All right, so it is a single replacement reaction. Check the charges. So +1, -1 again. Okay, and then the prompt said it was a solution, so or they said it was aqueous, so we know it's aqueous. All right, so we have all the formulas correct, but our equation isn't balanced. So we want to make sure we balance the equation before we move on to the total and net ionic portion. So if I see I've got 2 chlorines here and only have 1 chlorine over there, so I'm going to put a 2 here to balance that out. All right, then I look at the lithiums. 1 lithium here, 2 lithiums there, and so I need a 2 here to balance out the lithiums. Then I have 2 iodines and 2 iodines. Yay! Okay. Yeah, so Dylan, remember iodine, iodine's one of our 7 diatomics. 7 diatomics. Our 7 diatomics are hydrogen, oxygen, nitrogen, iodine, fluorine, chlorine, bromine. Whenever these elements are totally by themselves, they form 2s. Hahnefickelbar. All right. Okay, so what we've done now, if we go back to the problem, right, we go back to the worksheet, we've done the first part. We just did this very first line. Okay, but we need to now move on to the total and the net ionic. Okay, this is number 1 on the worksheet, Tiara, number 1. Okay. So to do the total and the net ionic, right? We remember what do we do when we go to total ionic? Yeah, this is on the worksheet that's due Thursday, Drake. So what do we do when we go from a balanced chemical equation to a total ionic equation? Yeah, we separate them, Matthew, but which ones do we separate? There's only 2 types of compounds that we separate. There you go, Cooper's got it. So aqueous ionic, it's got to be aqueous, Cooper. Aqueous ionic and strong acids. Okay, so chlorine is a gas, so that's not going to split. So we're just going to rewrite chlorine as a gas. Okay, lithium iodide has a metal, lithium, and a nonmetal, iodine, and so it is an ionic compound, and then it needs to split. You're good, Cooper. So we need to split it apart. Now, don't forget, when you split ionic compounds, the coefficients have to go through. And so this splits into 2 lithium ions and 2 iodide ions. All right, so chlorine gas breaks apart into 2 lithiums and 2 iodines. And then the iodine, again, this is a molecule because it's just a nonmetal element. And so it's going to stay together. And so we just say iodine. Even though it's aqueous, it's not a strong acid and it's not ionic, so it does not split. We look at the lithium chloride. It's going to split really similarly to the lithium iodide. Positive, negative. Thanks, Tiara. And so this is going to split into 2 lithium ions and 2 chloride ions. All right. So when they split, why don't the diatomic ones have it too? That's a really good question, Izzy. The reason why is because when you have something like chlorine gas, it's Cl2. But when you have an ion, the iodide ion is not the element in its elemental form. It's only when the elements are in their elemental form that they're H2, O2, N2, I2, F2, Cl2, Br2. So when they're breaking from a compound and they're an ion, they don't have the 2s on them. Don't go crazy with the diatomics. The diatomic only applies to this first line. All right. Hopefully that helped Izzy. Now let's look at it, Drake. So when we reminder, okay, so we've got the second line done. So we now have the total ionic equation done. Okay, total ionic done. So now we go to the net ionic. How do we go from total ionic to net ionic? Drake says something about a spectator. Okay, we remove spectators. So to be a diatomic has to be in elemental form. Yes, Cyrenius. There's one diatomic ion, mercury, but we're not going to talk about that. We don't worry about that. So yeah, we got to remove the spectator. So what's a spectator? What's our definition of a spectator? Something that doesn't change. Now we got to be careful when we say it doesn't change. It has to like not change at all. And so when we look at these chlorines, you see, oh, chlorine, right? We can cancel those out. We can't cancel those out because this is chlorine gas, Cl2 gas, and this is Cl minus ions. Those are different, right? So you cannot get rid of those. Okay. But when we look at the lithiums, 2 lithium ions aqueous, 2 lithium ions aqueous. Those are the same. So those are going to be our spectators, and so we can get rid of those. We look at the iodines, 2I minus, I2 aqueous. Those are totally different. Okay, so we're going to eliminate the spectators and rewrite the equation. So it's going to be chlorine gas plus 2I minus makes iodine and chloride ions. Yes, you can have multiple spectators, Drake. You can eliminate multiple spectators. You only write the charges when it's an ion split from something else. Yes, Izzy. Okay, make sure I didn't miss anything. Yeah, boy. So the rows correspond with a worksheet. Yes, they do, Trinity. These line up totally with a worksheet. We have our molecular equation, our total ionic equation, and our net ionic equation. Thanks for tuning in, Jackie. Enjoy your homework. You boy. That's... They're putting Community on Netflix, so if you haven't watched Community, that's a fantastic show. All right. Okay, so... Oh, it's already on it? Oh, Community is fantastic. Is the spectator something that doesn't change, or the things that are the same? Something that doesn't change, or the things that are the same. Hannah, those are the same things. So we're looking at the thing that doesn't change. They're spectators. They're not involved in the reaction. And so you eliminate them. I think I answered the question. Okay. I don't know, Ellie. The more that we're getting closer to the end of April, the less likely it's looking that we're going to go back to school. But there's been no official announcements yet, so we kind of want to wait on an official announcement that'll hopefully come probably next week. Okay, done with this. That's all I wanted to do for the review. I went a little long on review, but that's okay. So let's go back to Canvas. Okay, so a reminder, this worksheet, I'm going to have the submission for it I'm going to try to get that up this afternoon, but it is going to be due on Thursday. So you're more than welcome to do this on your own paper and then go from there. Can I just go get another sheet? Cooper, I don't know what you're talking about. Okay, so if we go back to this, right, we go back to our modules. There's something else in the modules that I added. I added this constants and reactivity series. Okay. I'll do like 5 or 6 again, Johnny. I'll make sure to update it this time, so I make sure to make that change so I don't mess that up like last time. Okay, stop freaking doing the SpongeBob meme to people's names. All right. Okay, so if you look at this, Cooper, if you look at the on the modules, the constants and the reactivity series, okay, what you'll see is this reference page. Okay, this reference page is going to be important. We're going to come back to it. I'm going to talk about it in a second. So at the top, Cooper, I'm gonna time you out. So we have the speed of light, Planck's constant, all these other ones. Okay. Let's go. So then this is the one we want to focus on. Is this thing called the standard reduction potentials? That's fine. I don't care. Yeah, so hey, good observation, Kate. So if you have your actual physical periodic table in your notebook, this is the back of it. I went ahead and posted it on Canvas because I wasn't sure if people had it. But I wanted to post this anyway. So if you have your periodic table, it's on the back of the periodic table. If you don't have your periodic table, you can get it from Canvas. All right, so we're going to refer to this here in a second. So let's go back to your notes. All right, so where did we end off your notes last time? I can't remember what like Roman numeral and stuff we were on. Let me look real fast. Oh shoot, I forgot the water. So those cannot be removed. Yeah. So let's do, this is Roman numeral 4. So this was an example. I'm going to go to a new page. Roman numeral 4. All right, so we're gonna do a new Roman numeral. We're gonna do Roman numeral 4. We're gonna call it predicting single replacement. Okay. So this is gonna allow us to predict if we can do single replacement reactions, right? So when we look at a single replacement reaction, we got to do a quick little review here. Right. So single replacement reactions follow the format AB plus C, right? Where the C would come in and replace either A or B. So, so we can make AC plus B. Again, this is if C is a non-metal. Hold on. Okay. People are spamming the chat. Go back to what, Tiara? The example problem? Example problem? Yeah. Okay. So AB, right? AB is an ionic compound. So we have metal, non-metal, ionic, right? And then reacting with some sort of a non-metal to make this and this. Okay. So we can have the same thing, AB plus C, right? It could also make CB plus A if C is a metal, right? It doesn't matter what A or B is. So A and B are always, since it's ionic, right? Remember, whenever we write an ionic compound is metal, non-metal, metal, non-metal, metal, non-metal, metal, non-metal, right? Tiara, you can just go back and pause it real fast. Okay, good. So yeah, so ionic compounds are always metal first and then non-metal. So that's why if C is a non-metal, it's going to replace the non-metal. And if C is a metal, it's going to replace the metal. So metals replace metals, non-metals replace non-metals. So it assumes the ionic molecularity of the compound. Yep. So in order for a single replacement, it's ionic compound plus some lone element. Okay. Now, we'll call this reactivity. Oh, not metal, sorry. So for an element to replace another in a compound, the replacing element must be more reactive. Okay, so for an element to replace another in a compound, the replacing element has to be more reactive. Okay. The replacing element has to be more reactive, right? So what this means is that, so let's look at this example for, right? So element C is attempting to replace element B in this compound. If in order for that to happen, element C has to be more reactive than element B. Right? If element C is less reactive than element B, then it will not replace it. Yeah, Serenius, but you're not going to have a free ion unless you've already like removed a spectator or something. You won't see that in that form. If you're going to see a reaction written like this, it's going to be an element. There are like in like a double replacement fashion, which we're going to talk about later, like on Friday. Then it is going to be the ion that's going to have that same effect. But this is more in this format that we're looking at. How are we supposed to know if it's more reactive? Ugh, is he asking the great questions, right? So that is what this reference chart is for. So, okay, I'm going to move on to number 2. I'm going to do that in a second. All right, so again, for an element to replace another in a compound, the replacing element must be reactive. So how do we determine reactivity? Is by looking at the chart that I'm going to pull back up in a second. So, number 2. Now, fluorine, you're good, Zach. Fluorine is the most reactive non-metal. So if we go back to the canvas, okay, and we go back to this reactivity series, oops, here it is, okay. If I zoom in on this, right, so in terms of singular elements, right, in this fashion that we're talking about, fluorine is the most reactive element. So you'll notice fluorine is on the bottom of my chart. Okay, that's a key point. So let's go back to this. So for non-metals, oh, I can't spell. Non-metals, look at the left. All right. Oh yeah, my children screaming. Most popular, whatever. Found lots of stuff. Oxygen is very reactive, Enya, but it's not as reactive as fluorine. All right, let me see if I can explain this a little bit more. Okay, so for nonmetals, you look at the left column, and the bottom, fluorine, is the most reactive. So let's go back and look at some other elements here. I'll bring this back up if you haven't copied this down. So let's go back to the canvas. So if we look, right, so fluorine is our most reactive nonmetal. Okay, right above that, we have don't worry about the cobalt, but we have chlorine, right? And then we have oxygen. Okay, so fluorine is most reactive, and then chlorine, and then oxygen, and then bromine, and then, let's see, iodine is pretty weak. Sulfur, very non-reactive. Yeah, so not fluoride ions, Cooper. Fluorine gas. Different idea, fluorine gas. Fluorine gas is incredibly reactive. Fluoride, the ions, not reactive. So actually, Enya, it's by using these single replacement reactions, right? If I have a compound, say lithium fluoride, right? So I have lithium fluoride together, and then if I add oxygen gas to it, there's no reaction. But if I have lithium oxide and I add fluorine gas, there's a reaction. So it's the idea of you can do a series of reactions and you can find which compound is the most stable because that one isn't going to react. Okay, so that makes sense. So is fluoride only that reactive as a gas? No, so I guess if you manage to get liquid fluorine, it would be very reactive, Cooper, but I don't know anything about liquid fluorine. Yeah, so these are experimental data. This is data from experimentation. This is not anything fundamental about the elements. It's what we've observed through reactions and reactivities. That's a great question, Enya. So, like I said, Cooper, they measure it by how they react. Okay, so when we look at here, we'll do some examples in a second here. Oops, wrong one. Sorry. There we go. So number 3, for metals, right? We want to look at the right. All right. So For metals, look at the right column, the top, the lithium is most reactive. So because, remember, metals and nonmetals react in a different way. Metals react by losing their electrons, and nonmetals react by gaining new electrons. And so that's why our chart is opposite for metals and nonmetals. So if we go back to this canvas real quick, right? If we look at the top of the column, you'll notice we've got all these metals. And yet all that matters is just referencing this chart. There are some small trends when it comes to charges and things like that, but it really is just this chart that they've done from experimental data, which is why we're just going to use this chart as a reference sheet to be able to predict this. Okay. So, if you notice, lithium is in the top, right? So lithium is the most reactive, followed by potassium, barium, calcium, sodium, magnesium, aluminum, manganese, zinc, etc. Now, this list isn't comprehensive. How do you get negative rates? Oh, okay. So this value has to do with electrical potential, which we unfortunately will not be able to get into talking about. So yeah. So don't worry about this negative chart. That's not a big deal. Yeah. So don't stress that. But yeah. So lithium, potassium, barium, on down to gold. Gold is very non-reactive, right? That's why people make jewelry out of it. Yeah, unfortunately, we because of the restrictions due to COVID-19, we are probably going to run out of time and not going to be able to get to it. That's the one thing we decided to cut. I have no idea, Cooper. I was asking myself the same question. All right, so gold is the least reactive metal, and lithium is the most reactive metal according to our reference sheet. Again, it's not an all-encompassing list, but it's a pretty good reference. So let's do a quick example of how we can use this chart, right? So let me close this. All right. So this, we'll call this letter C. Examples. Let's do something. Will zinc react with a solution of magnesium nitrate? All right, so here's the question. Will zinc react with a solution of magnesium nitrate? So if we write out the reaction, okay, zinc solid plus magnesium nitrate, MgNO3. All right, so zinc by itself, magnesium, right, we check the periodic table. Magnesium's in the second column. It's a +2. Nitrate we should have memorized as being a -1. So +2, -1. We know we need 2 of those to balance it out. Okay. Now that's not super important for answering the question, but okay. What in the world? I usually get them uploaded to YouTube within the hour. Stop calling people illiterate. Yeah, so aqueous. Sorry, my Q is looks like a G. All right, so will zinc replace magnesium? Okay, so first thing we have to check, okay, these are metals, right? So these are metals, and so we need to see, is zinc higher up on the chart? Is it reactive enough to replace magnesium? So we go over to the chart, okay? We go over to the chart and we see, all right, where's zinc? Zinc's here. Okay. Magnesium is up here. So magnesium is higher on the list, and so magnesium is more reactive than zinc. So since magnesium is more reactive than zinc, the zinc cannot replace the magnesium. Oops. Okay, so what we would do is we would say there is no reaction. Or we could just say no. Right? Will zinc react with a solution of magnesium nitrate? No. So there's no reaction there, right? So let's do another example. Let's do, let me just kind of tack this on here. Let's call this number 2. Will zinc react with a solution of, let's just pick something like, oh, I don't know, we'll say tin. Tin sulfate. Right? So, will zinc react with a solution of tin sulfate? So zinc, right? Zinc, zinc, solid. Tin is SN, sulfate, polyatomic ion, SO4. Oh shoot, I should say the Roman numeral there. Sorry, tin 2 sulfate. Yeah. Thanks, Cooper. Thanks for the catch. Yeah, it's tin 2 sulfate. So if the tin's a positive 2, sulfate's a negative 2, and so that just works out. So we have zinc plus tin 2 sulfate. Okay. So this is where we go to the chart, right? And we say, all right, let's check our graph. Okay. So we have tin is down here. Whoops. Oh my gosh, highlighting problems. Okay, so tin is there, and the zinc is up here. So in this case, the zinc is higher on the chart, and so it's more reactive than the tin. So because the zinc is higher and more reactive, the zinc will replace the tin in the reaction. So will it react? Yes. Right? And so our products here are going to be zinc sulfate and solid tin. I'll grab some stuff and I'll show you guys this reaction. This is a pretty cool reaction to show. Not this one specifically, but the actual single replacement is pretty cool. I'll see if I can grab the chemicals to show it. So, okay. Why, Zach? What are you confused about? So it's a single replacement reaction. So the zinc replaces the tin because the zinc is more reactive than the tin because it's a metal and it's higher up on our chart. In this last problem we did, zinc is lower on the chart than magnesium, and so zinc is less reactive than magnesium, and so in this case there would be no reaction. So that's what this whole thing that we wrote down is saying. For metals, look at the right column, the top is the most reactive. For nonmetals, look at the left column, the bottom is most reactive. And then if we go back to what we wrote previously, for an element to replace another in a compound, the replacing element must be more reactive. So we're talking about the chart on Canvas. This chart. The standard reduction potentials. Thanks, Serenius. Yes, Lauren, that's a good summary. So the element itself has to be more reactive than whatever's in the compound. If you're just a random person tuning in, you can just look up standard reduction potentials table, and that should bring up a very similar document. Okay, we are running out of time. This is actually all I wanted to get through today. That's all I wanted to talk about. Reminder that on Wednesday we'll be discussing the rest of this worksheet, right? So make sure that you spend some time today and tomorrow working through this worksheet. Okay, it's a lot. It should take a pretty good amount of time. It will probably take an hour, not a little longer. Let's see, Kai's question: if one is on the left of the chart and one on the right, which one is more reactive? So Kai, that's not going to happen, right? So if we look at this chart, let me do a general. So script. There's some good resources online, but I can't think of any good free ones right now off the top of my head. I'd have to look into it more. So let Cooper. That's a really good question. Let me talk about the chart a little more in depth. I've kind of glanced over this chart a little bit more. So, I don't know. That's a hard question. Any of the main publishers is going to make a good text script. So, if we look at this chart, the zeros. No, I don't have drops, Micah. The zeros, right? So what they've done is they used hydrogen as their baseline, and they compared everything to hydrogen. Yeah, so the thing is if you look, these are reactions. These are technically showing how these elements react when they gain electrons. And so the reason why we look at the bottom, because we're looking at the nonmetals gaining the electrons from the bottom left. So anytime you have a single nonmetal, you're going to look at the bottom left. And then if you have a metal, you're going to look at the top right. So what this is showing that lithium really doesn't want to gain an electron, meaning lithium is very reactive in losing its electron. Similarly, fluorine is very strong at gaining electrons. So here, I'll drop a link to one of the main ones. Let's just do. Let's see. Okay. You guys are talking about hair dye, nothing important. I think so, Cooper. I think we're going to be done for today. Let's do... Sorry, I'm trying to find a good one. Yeah, Zoom Doll's probably the biggest one. Let's go with Zoom Doll. Zoom Doll's a really popular book. That's a good popular Gen Chem book. It is, Izzy, you're right. It's a mechanical keyboard, so it has good response. I also have I have Razor Green keys, so they're really clicky, but I like clicky. I don't have any Chacos, Ellie. Okay, so that's going to be it for today. That's as far as we're going to go. I don't want to do a ton of other stuff. I know I need to get bots and all this other stuff going. I'm going to try to work on that tomorrow, maybe. Try to up the stream quality a little bit. I just haven't gotten around to it. Yeah, sometimes stock keyboards are actually pretty good. Cherry MX Blues. I got Razor Greens. I love my green switches. They're so loud. All right. Hey, thanks for the follow script. I didn't see that. So all the problems you give us will have the elements compounds on the paper in the middle column. Okay. Not necessarily, right? So if we look at this chart, the metal elements are on the middle column. Okay, so metals are on the middle. And then the non-metals, there's only a couple non-metals. Fluorine, chlorine, oxygen, bromine, iodine, sulfur. Those ones will be on the left. Right? But a lot of them, if you have a metal replacing another metal, you're going to go here. Okay, everyone's talking about keyboards. So Izzy, their difference in the columns, right? So this is lithium solid. So this is as a metal element. This is what you're going to be looking for as the solid. This is lithium ion. That's different. Okay. You can just ignore the electrons, Lauren. Yeah. Okay. Other questions. So, TR, to answer your question, when you have a keyboard, right, they technically have switches on them. When you press down, there's a switch that'll go on a mechanical keyboard, and there's different types of switches that have different responses. And there's some people that care a whole lot about it. There are some people that get really technical into it, but it's not super. Just some people love it, so. We are going to cover those on Friday, Cooper. On Wednesday, remember we're only doing Monday, Wednesday, Friday stream. So on Wednesday, we're just going to go over the worksheet. That'll be most of the time. And then on Friday, we'll talk about how double replacements and things like that work. So the worksheet, you don't need to know this to do the worksheet. You don't need to know this to do the worksheet. Man, Xander, you're really far behind. Nope, it's just Monday, Wednesday, Friday for this, Monday, Wednesday, Friday for AP. Yeah, the worksheet you've actually known how to do for a while. You guys just haven't started it yet. So you don't need to know if something's going to replace it. Nice, Ellie. You can call people fools. Yeah, I do. I think it. Well, I always wear shirt and tie when I teach. Not necessarily always when I stream. If I'm streaming like video games or something, which I do for every now and then in the evenings, I won't. But whenever I'm teaching, I'll wear shirt and tie. Okay, let's go ahead and close out the stream. I'm going to do AP here in another half hour, but we'll be done with honors. Work on your homework. I'll have the submission hopefully done by this afternoon, if not tomorrow morning. And we are going to be done. So, see you guys. Have a great day. I'll be in the Discord for help this afternoon if you need help with homework. This afternoon and tomorrow. And then we'll be streaming again on Wednesday. Thursday is the next assignment.